Okay, so next material I found helpful from this website, and it's example here that I really think it's helpful.
Oh.
Here you
Mhm.
can I'm not sure if you can understand the shorthand here, but let me explain the shorthand to you. So this
Delta
one,
H.
the delta HF means
Mhm.
heat formation.
Right.
So which is the formation you can from this to this, because you can see the arrow point to this. So
Mhm.
it's combining something, so they're releasing energy. That's why this is negative here.
Mhm.
And this one, change the enthalpy of atomization. And you can see the atom here. Oh,
Mhm.
okay. So that one, it is changing this one from solid ch to gaseous stage. You can see the arrow here. So
Huh.
it's adding energy. You can think of like heating it until it become gas, right? So the next one here is change enthalpy of ionization. And
Oh.
so the ionization, you can see the only difference here is on here. We removed one electrons, which caused the Na to be positive charged here. So when
Oh.
we're removing it, we are also, adding energy to it to do that. So that's why this number here is positive. And the
Right.
next one is the energy to change this Cl2, half of Cl2 to this Cl here, because we're, changing this part to 2Cl, but it's half of it. So it becomes just one of
Oh, yeah, yeah.
that. So that's the energy needed to change half of it.
I see.
It's also the dissociation energy we mentioned before.
Right.
Yeah. So this one is the electroinfinity here, and is symbolized here. You can see there's a E, but sometimes I write EA just to symbolize electron infinity.
Mhm.
So you can because you can see the change here is this one becomes Cl negative minus charged because we add one electron to it. That's what caused it to be negative charged.
Mhm.
So when we add something to it, we are releasing energy. It's a reverse of, break something apart.
Right.
So that's from there to there. So you can see two of them are in gaseous, two ions are in the gaseous states right now, right?
Mhm. Yeah.
So the process of us um, changing this to this or from this to this is called a lattice energy, right?
Huh.
Gaseous. Yeah, two gaseous ion to something solid or some compound solid compound to get gaseous ions is called lattice enthalpy change, which is what we need to calculate here,
Oh.
right?
Yeah.
So
Okay.
so so we can do that in thinking of terms like we could just add the energy spent on the weight here. So add it all of those to get this part, right? All
Oh.
of them to get this part.
Uh-huh.
Um, but you can see the arrow here is reversed. That
Right.
means we need to change the arrow to make it so we can add it. And the
Right.
changing the arrow means we need to change the side of the energy here. So that's why we have a minus minus here, which makes it positive. You can
Right.
see from here it's going from um, this step to here, but I personally think it will be easier just to reverse it here. So what I usually do is reverse this one, which will become 411. If you have a calculator, you can do it with me here or phone something. You can see like we put positive 411 kilojoule more and add the next one is 107. Then add the next one, which is 496. Then add the next one which is 242 here. Then we minus here because it's a negative enthalpy change here, so we minus say 349 here, which will give us
Hmm.
wait a minute.
Yeah, I got a 907.
Yeah, I got a 907 too. So let's figure out. Oh, I see. Because we didn't calculate the 1/2 year.
Ah,
So let's just copy that and add a 1/2 there. Add the 1/2. Okay, now it gives us 786, right?
yeah.
Yeah. So that is yeah. So in the whole and when you're thinking this whole picture, so you can think of it as just what we can do to get a something to gaseous states to this compound solid or get this compound solid into the gaseous states. But
Mm-hmm.
from its natural states, which is usually where we start, it's here, right? We start
Ah,
at its natural states, which is solid for Na and gaseous for here. We need to track the steps that needed to do it, which is why they did this one first. Because this one we first the first step is we turn both of them into gaseous states,
mm-hmm.
then we dissociate them, or you can do the ionization or dissociation. It's kind of like an equivalent level of steps here. You can call both of them step two. Doesn't matter which one you pick to be first, because it wouldn't cause any change. And the next one will be we'll you know um, change them into single gaseous gaseous atom here, and make sure they are all ionized in the accordingly charged, because in like a one plus needs one minus charge. If it's
Mm-hmm.
two plus, then it needs two minus charge. So sometimes we'll see like it has two plus charge here, and we something is just only minus one charge here. That means we need a two here, because two minus
Uh,
charge is minus two, right? So
mm-hmm.
so that would make it equivalent to, and that is why we are taking those steps. It's just those steps we needed to change two gaseous ion into a solid compound, or turn a solid compound into two gaseous ions. So
Huh.
yeah, so it's pretty simple, and I found out when I was doing most of homework, I can just reverse this one, which is just the heat of formation, and to positive, and add all the rest of it together. That will just give me the lattice energy.
Oh, wow.
Yeah. Do you think it's helpful?
Yeah.
Okay, I'm glad to hear it.
Yeah. Thanks.
You're welcome.